Okay, it's Saturday morning. We just woke up and the house is about 80 degrees inside and the thermostat is set at 70 degrees. So obviously the air conditioner is not working. When we come over here and stick our hands in front of the registers, it's blowing air, but it's blowing warm air. So we come out into the garage, you look up at the air handler, and the air handler, you can hear it blowing, plus the fact that we could feel the air blowing. We know the air handler is working. It's just blowing warm air instead of cool air. The fact that the air conditioner worked perfectly last night indicates to me that it is probably not low on Freon, because if they're low on Freon, they get a little bit low and then lower and lower and lower. So what it'll do is it will keep the house good and cold, and then not so cold, and then even less cold, and so on. And it takes several days for it to fade away to not working at all. This was working perfectly 1 minute and totally not working at all the next. So the air handler is blowing. We've got to see what's wrong with the compressor. We get a couple of tools to do some testing with. Okay, this is a 3-ton compressor, so it's obviously a 240 volt compressor. So the voltages that we're going to check are primarily going to be 240 volts. Okay, fortunately, they've given us a wiring diagram right inside the compressor access panel, which is going to help us a lot. So the first thing we want to do is, when we walk out here, you notice the compressor is not running. And that's your first clue that the problem's in the compressor. So we're going to check power coming into the compressor. And the compressor power comes in through these wires, through these wire nuts, to the contactor. So the best place to check for power is on the input side of the contactor. So I'll go ahead and set my meter to 240 volts AC, and we'll check input side of the contactor. Now we look over at the meter, and sure enough, we're getting 244 volts, and that's good. Real quickly, with a 240 volt system, if you are getting 120 volts, that means either the A leg or the B leg has failed. This would be the A leg, this would be the B leg, and then you would have a neutral. Since this is a 2-wire system instead of a 3-wire system, we don't have a neutral, but I can show you how to test it anyway. You would go put 1 meter lead on the A leg and the other meter lead on the ground, and then if you look at the meter, you should be seeing 120 volts, and you are. Then you come back over to the contactor, and you go to the B leg this time, and to ground, and you look back over at the meter, and you'll see you're getting 120 volts there. If you were only seeing 120 volts on either the A or the B leg, you'd know that there was a problem with power coming in, but that's not the case here. We definitely have 240 volts coming into our 240 volt compressor. So now we want to check power coming out of the contactor. So we'll go to the top 2, and we should also see 240 volts. And if we look at the meter, we're not seeing anything. So we know that the contactor is not engaging. So now we need to find out why. And if you look at the wiring schematic, the control board has a yellow wire with a black tracer outputting 24 volts AC. And if you look at the contactor, you'll notice that the coil is a 24 volt AC coil, so that's good. It's the right one. FLA is full load amperage, and that's a 32 amp. The volts, it's a 240 volt system, and LRA is lock rotor amperage. So what we're going to do now is we're going to measure the voltage from the black with the yellow tracer coming out of the control board to ground, and we want to see 24 volts AC when we look at the meter. We look at the meter and there's 26 volts AC, and that's good. That's what we wanted to see. So now from the control board, it goes to a temperature sensor on the compressor, and then from the temperature sensor to a high pressure cutout switch, and then from the high pressure cutout switch to the contactor. So now what we're going to do is, since we know that it's setting out the 24 volts from the circuit board, we're going to check after the temperature sensor. So when we measure from the temperature sensor to ground, and then we look at the meter, and we should see 24 volts there also. And we do. So we know our temperature sensor is good. The next thing is, it goes from the temperature sensor to the high pressure cutout switch. And the high pressure cutout switch then goes into the contactor. So if we measure from this yellow wire on the contactor to ground, and then we look over at the meter, you see that we have our 24 volts. And then we come back over here. So we know we've got 24 volts going into the contactor. And we've got we've got 24 volts going into the coil. The contactor has 240 volts, but yet the output has 0 volts. So we know that the circuit board is working. We know that the high temperature switch is working, and we know the high pressure cutout is working. The problem appears to be in the contactor. So we're going to do a quick test. The easiest way to test this is, you see this button right here. If you push in on this, the compressor should kick on. And it does. We release it, and the compressor comes back off again. If, when we had measured the power coming out of the board and going into the high temperature switch, if it had not had power coming out of the board, then we would have said it was a bad board. If it had power coming out of the board but not coming out of the high temp switch, then we would have known it was a high temp switch. We cannot we cannot repair the low pressure cutout or the high pressure cutout here, because we'd have to decharge the system. And the only way you can get Freon for this is to buy the large containers of Freon. So we now know that we have a bad contactor. So what we'll do is we'll look up the contactor and get a new one. Things to point out on you. Number one, this is a single pole contactor, and it can be replaced by a single pole or a double pole. They chose a single pole because, well, there's nothing made today that somebody can't make just a little cheaper and a little lousier. So if you put a 2-pole contactor on there, you're fine. The numbers that you need to keep in mind are the FLA, and that's full load amperage. And on this one, it's 32. The volts AC is 240 volts, and that would be 240 as opposed to 120. And then the LRA is lock road amperage, lock rotor amperage. And then, of course, the fact that it is a 240 volt on the contactor side. The coil side on this one is a 24 volt, and it indicates 24 volt right across here. So that's what we're going to be looking for. So right now, I know that if I push in on this button, my house is going to be cooled down. So what I'm going to do is I'm going to take a jumper and jump from right here to here. And that way it will cool the house down. And I'll come out here in about 30 minutes and I'll pull that jumper off and let the house warm up again, and then put that back on, because as I said, it is Saturday morning and we're not going to get new parts right away. If you purchased a new contactor and it was a 2-pole, you'll notice on this side, it's just a jumper. On the 2-pole, instead of the single pole, they would both be switched. And you would simply hook the blue to one side and the green to the other side, the same way it is here. But both sides would then be jumped. And when we go inside, we're going to look it up and see what we can find and see if we can get this exact contactor. If we can't, we'll get a double pole contactor. That's not going to hurt a thing. So let's go on inside and I'll get a jumper to put on that so that we can have air conditioning for the rest of the day. So I found a replacement contactor and they're only $12.99. So at that point, you could almost walk out there and just push in on that little tab to engage the thing. And if the air conditioner took off running, you could almost justify ordering a contactor at that point. I'm noticing that it says delivery tomorrow, and this being Saturday morning, there's no way I could get an air conditioning repairman out here this quickly. They'd show up on Monday and they'd get it fixed on Monday. As a result, Sunday morning, I'm going to have an air conditioning unit that's running correctly. Again, there are numbers to remember, and this has got several options. There is a 2-pole, 240 volt, 40 amp. Now, you'll remember that ours was a single pole contactor. And as I said before, you can use a 2-pole where there used to be a single pole just fine. You can't use a single pole where there's supposed to be a 2-pole. Here is a 120 volt, 30 amp 2-pole. And here is a 40 amp, 24 volt coil. Down here is a 2-pole, 30 amp, 24 volt coil. So this is the one that we're going to order. And it's only $12.99. And according to them, it'll be here tomorrow morning. So this certainly beats the daylights out of waiting 2 days to get an air conditioner repairman out here, only to get a bill of several $100s. The other thing, the fact that this is only $12.99, it almost justifies when I walked out there and looked at it and found no power coming out of the contactor. If I had just poked in with a screwdriver to do the test of the contactor and the thing came on, at $12.99, it almost justifies replacing the contactor already, even without any more tests. But I am glad I did test to find out that the high temp cutout switch and the high pressure cutout switch were good. We know the low pressure cutout switch was good because the board was sending the signal, and the low pressure cutout is handled entirely independent of this. So let's go ahead and get our contactor ordered and we'll go from there. Now that I've found a link or a site that has all these different options, I'm going to go ahead and include a link to this exact page so that you can see what the options are. And as I stated earlier, you can always put a 2-pole contactor where a single pole came out. So between these options here, you'll be able to get a contactor that'll work in your air conditioner. And you'll notice the mount brackets are identical to the one with the single pole. So let's go ahead and get this ordered and we'll have a good weekend. Wow, that's interesting. The camera shooting 30 frames per second creates a strobe effect to make sure, or make it look like the blades of the fan are spinning backwards at a very slow speed. I can assure you they're actually spinning forward at a very high speed. At any rate, the part came in, the contactor, and I installed it, and everything's good now. Unfortunately, I got a little excited and got in a hurry and forgot to videotape the install. But the procedure is very straightforward and simple. Take your cell phone and take plenty of pictures of the old contactor and of every single wire going into the old contactor and the wire routing. Then unbolt the old contactor, put the new one in, and refer to your photographs on your cell phone for the wire location, and make sure that you get every wire in place. So there we have it, $12.95 to repair an air conditioner that if I had gone with the air conditioner technician, number one, they wouldn't have been here till tomorrow morning at some time at the very earliest. And I say the very earliest because I wouldn't be able to contact the company until tomorrow morning. And if they sent somebody right out, we'd probably be waiting a little bit longer, and very likely spend a couple $100 just to have him come out and do an estimate on it. But if you look real quickly, you'll see that there's now condensation forming on the low pressure hose, so you know it's getting cold. And if you take my word for it, there's definitely cold air blowing out of the register. So not bad, $12.95 for an air conditioner repair.